Okay guys, so now coming to a final part of this entire operation that we were trying to perform. So we were able to take our own data. Eventually we were able to convert our data into a chunks. Then we are able to convert our data into a embeddings. And then we are able to store our data into a vector database, which is a in memory I have taken. Okay. Now, so the next step is going to be query that particular vector DB that we have created, the indexes that we have created, and then try to retrieve some sort of information out of this one. And with the help of LLMs, let's format the final result and then show it to you. So this is going to be the final step, and this is where we are going to understand end-to-end how RAG is going to work. A retrieval augmented generation is going to work. So what is the meaning of a retrieval? What is the meaning of augmented? And then final generation, you will be able to understand all three words in a sequence. Okay. So let's move ahead, and this is the structure which I was talking about, by the way, right? This is the structure which I was talking about. So let's try to do one thing. So let's try to create a query, and then I will try to query my vector DB. So whenever we try to do a query, generally we try to do a query with respect to LLMs. But in case of a RAG pipeline, so in case of a RAG application, so we are not going to do a query directly to the LLMs because it has to give a response from my private data, right? A data about which LLMs are not aware about. So what I will do is I'll try to query a vector database, and inside a vector database, I have a embeddings which is available, right? So I have a embeddings. All of these embeddings means my information is available in a layman way. Yeah, my information is available basically in a numerical format. In a numerical format, my information is available. So what I will do is I'll try to query this Facebook AI similarity search database, and then based on my query, I will try to extract a top result, maybe top 1, top 2, top 3, top 5, whatever, right? Whatever I want. So I will try to retrieve those information, and then those information which I'm going to retrieve, right? Those information which I'm going to retrieve plus the query which I have sent. Again, remember this guys, this is very much important, right? And many people gets confused over here. So whatever information which I am going to receive from my vector database, whatever top information which I'm retrieving, plus I'm going to append my query. Yeah, plus I'm going to append my query together, and I will send those entire information to whom? To my LLMs, right? To my LLMs, to my large language model, so that it is going to format the entire response. It is going to make it polished, and then you will be able to receive a final structured response. So now let's do one thing. So here is a very small function I have written, a retrieve top k. Retrieve top k means what? So query, you are going to send any kind of information. Maybe you can try to ask that who is Sudhanshu Kumar, because the data set was all about me. Data set was all about a founder story. So who is Sudhanshu Kumar? So what it will do? So it will try to convert this query into an embeddings, means into this particular format of size 1536, because that's what this embedding is going to return, right? This function is going to return. So it is going to basically give me a embedding, and then you are going to do a search. Where you are doing a search? Index.search. What is this index, by the way? Index is my Facebook AI similarity search database object. So it is going to do a index.search, and it is going to search this query, and then it is going to return you something, right? Then it is going to return you something. So what is that something that we are looking for? So see, what it does is that inside that, based on the cosine similarity, or based on the Euclidean distance, or based on any other, right? Any other like a similarity check algorithm. So where it will just try to check the distance. So in a layman way, so unless and until I'm not talking about this, how search actually happens and what are the algorithms which is available, because there are multiple algorithms which has been supported by even Facebook AI similarity search in terms of matching the data. In terms of matching the data means we have this vector, right? We have this particular vector, and we are trying to create again another vector. So we are trying to check that, okay, so which one is nearest? Which one is nearest, right? So in a layman way, if I have to explain you, right? So maybe I can try to explain you in this manner. Let me, open up this one. So see, let's suppose if I have given you two coordinates. So I have given you basically two coordinates. So here basically it's a x1 and then y1, and then it's a x2 and y2. I have given you this coordinate, right? I have given you this coordinate. Now, if I'm going to ask you, this is point A and this is point B. Now, if I'm going to ask you that what is the distance between these 2 points? Now, this is also vector, right? This is also vector because it is representing a magnitude as well as it is representing a dimension, right? In a dimension in a 2D space. So if I'm going to ask you that what is the distance between these two, so maybe you can try to choose maybe a Hamilton distance, maybe Euclidean distance. So here I'm going to use Euclidean distance. Euclidean distance is what? So x1 minus x2 square plus y1 minus y2 square, right? So this is going to give you a distance between point A and a point B. Simple. This is going to give you distance between point A and point B. Now, similar kind of operation is going to happen even over here. So whenever I'm going to fire my query, right? Whenever I'm going to fire my query, so it is going to convert my query into a embeddings. Now, this embedding, right? This embedding will be checked with the embedding which is available into my Facebook AI similarity search database, because even inside this, what we have, so we have eventually embeddings of my original data, right? So it is going to check, it is going to check basically like a top 10, top n, or maybe top 3, top 2, whatever you want, right? So it is going to check that whatever query which I'm going to fire, so with respect to this query, what kind of a data set we already have inside this vector database, right? Vector database, and it is going to return you a top result. It is going to return you top result. Now that top result depends upon me. That top rank depends upon me. I can look for 1, I can look for 2, I can look for 3, I can look for n. That completely depends upon me, that what is the top result. So similarly, so the nearest one, it is going to give you in a first place. The second nearest one, then the third nearest one. This is how it is, right? This is how it is. So this is not a rocket science, by the way, that we are trying to learn. This is a very simple fundamental concept that we are trying to learn over here. Not a rocket science at all, means literally not a rocket science at all that we are trying to explore in this particular place. So here it is going to like get top 1, top 2, top 3. So the nearest one is going to be top 1, then top 2, then top 2, top 3, and top n. It is going to return. You can try to do an experiment to make your RAG better and better, more contextual. So it is going to return it, and whatever it is going to return, let's suppose it is going to return this top 3 values. For example, I'm trying to extract top 3 values. So with this top 3 values, I'm going to attach even my query embeddings. So query embeddings, I'm going to attach. Now this will become my whole data. This will become my whole data. Now this data I'm going to send into the LLMs. Now what is the roles and responsibility of LLMs? So roles and responsibility of LLM is to format this entire information, whatever information that we have, right? Format this entire information and give me in a polished way. Give me in a way so where human will be able to read, I and you will be able to read, as simple as that. But it is giving me all the responses based on what? Based on my own query and my own data, which I have stored inside my vector database. Simple, right? Simple. So even LLMs, how LLMs, forget about that. So that's a different story. Maybe I'll not try to open up that story now. In the future, I'll try to open up that story. Okay. So here, what will happen is that it is trying to retrieve a top k, right? I have given k is equal to 3. I can give k is equal to even like a 4 over here. So top 4 nearest embedding vector, it will try to like extract, and then it is trying to return me what? So it is trying to return me basically a chuck mapping for that one. Chuck mapping for that one means what? So if you remember what we have done, so we have basically CHU, CK, CHUNK, chunk mapping. Chunk mapping was what? This one, right? The final list that we have created. So where we had all the chunks available to us. Yeah, all the chunks available to us in a original format. So one by one. So it is going to give me like extract it, and then it is going to return me this one. So for like a top k is equal to 4, whatever that we were looking for, right? So it is going to return me this entire information. Okay, execute it. Now, so this is done. Now what we have to do is, so we have to prepare basically a prompt, right? We have to prepare basically a prompt. So here what I'm going to do is, so I'm going to write this very simple function. So inside that it's a string. As you can see, this entire selected part is basically a string. Now this string is a formatted string. It is taking what? So it is trying to take a couple of input, right? It is trying to take basically a couple of input over here. So I'm just trying to build the prompt over here that whatever chunk that we have received from my vector database, right? Whatever chunk that we have received from my vector database, and then whatever query that I have, right? Whatever query that I have. So accordingly, try to build a prompt. So use the following context to answer the question. So context is what? Context is something that we are getting from the chunks, means from my vector database, right? So we are trying to extract the embeddings, and then eventually we are trying to find out that, okay, for this embedding, what was the total, like what was the line basically, right? What was the line? And then question, query I'm trying to attach. So this is the whole string I'm going to prepare. Just a string, just a plain simple string we are trying to prepare. We are not doing anything much, right? We are not doing anything much. So this is my build prompt function. And then what I will do is, so I will try to call, right? I will try to call basically a chat completion function that I have introduced you in a very first lecture. So calling my LLMs, guys, by the way, nothing different, right? So calling my LLMs basically, so that I will try to pass my entire message. I will try to pass my entire prompt, and then I will be able to get the response. So I have just manipulated my temperature. Maximum token is 500. This is the prompt it is going to take as an input, and then I can change my model over here. So I can try to use maybe a llama, maybe a DeepSeek, or maybe a Maverick, whatever I want. I can try to use it. I have an access of a multiple models inside EURI, and EURI API key already I have given. So this is going to like hit it with my prompt. What is my prompt? Prompt is nothing but a plain string, but inside this string, I have two things. I have my query, and I have a retrieved data from my vector database, right? Retrieved data from my vector database I have. So, okay, execute it. So all these functions are done. Now what I will do, I'll try to prepare my query over here. QUERY query I'm going to prepare. Now I'll try to show you the demo. QUERY query. So query is equals to tell me who is Sudhanshu. Yeah, it's because I have taken a founder story data. So tell me who is Sudhanshu. Now, whenever someone is trying to fire a query, right? Whenever someone is going to fire the query, you have to follow what approach? You have to follow this approach. So you have to convert that into a embeddings, and then you have to extract a relevant information from a vector database. Okay, fine. So whenever someone is going to fire the query, so I'm going to call basically a retrieve top K. And then inside this, I'm going to pass my query is equals to my query over here. So I'm going to pass my basically query. QUERY query I'm going to pass. This is what it was taking, right? It was taking a query, and then K is equal to 4 I have given, means just give me 4 similar, like a 4 nearest result, as simple as that. So K is equal to 4. If I would like to manipulate, I can try to manipulate it. So this is going to retrieve, right? So once I'm going to execute, as you can see, it has given me 4 lines, right? It has given me 4 lines. It has given me basically 4 lines. 4 lines is coming from where? So 4 lines is coming from my vector database, index.search. It is trying to search the indexes, and eventually I'm doing a mapping over here, a manual mapping, right? That whatever indices it has returned. So just try to do a mapping that this belongs to which one. Means I'm just trying to show you like a result in an English format, readable format. Otherwise it will be available into a vector format. Okay. So I'm able to like extract this entire like a result. So this is the result of the retrieval top K. Now, if I'm going to write K is equals to maybe like a 2, it is going to give me only 2. So it is going to query, and it is going to give me only 2. So 2 sentences it is trying to give me, as simple as that. So like as of now, more is better. So here I'm going to like write maybe 4. That's completely fine. So 4 things it is going to retrieve. Now I'm going to store this information into some of the variable. So top chunks. Okay. So top chunks I am able to receive. Now, whenever I'm going to receive a top chunks, I have to call what? I have to call a build prompt. So now let's try to build a prompt. Yeah. Now let's try to build a prompt and pass the prompt inside my LLM. Simple. So here I can try to call my build prompt, and here, so what I can do is I can try to pass my top chunks and query, because this was taking what? This was taking basically a query, means top chunks, whatever chunk that we have, plus query, right? Plus query, so that my LLMs will be able to understand a question as well as the data that we are trying to retrieve. So here a query. So I'm just going to pass the query altogether. So this is going to return me what? This is going to return me basically a prompt. Now you can see that prompt, you can check that prompt over here. So use the following context to answer the question, and as you can see, whatever it has retrieved. So, and plus the query, who is Sudhanshu? Tell me who is Sudhanshu, right? Just tell me who is Sudhanshu. It is trying to append each and everything, and then it is like trying to build the final prompt. So this is my prompt that I'm sending to my ChatGPT, or my GPT model, by the way. Yeah. So here prompt I can try to write, and then this prompt I will be sending where? So I will be sending in a generate completion, so that it is going to hit my EURI API where I'm calling my GPT 4.1 Nano. Yeah. So here, basically it is going to call a generate completion, and inside that it is going to hit a prompt. Prompt is equals to prompt, by the way, and it is going to give me a response. So now this is called as final retrieval augmented generation. So Sudhanshu is an accomplished technologist, entrepreneur, and educator who hails from Jamshedpur, Jharkhand. Overcoming financial hardship, he pursued a degree. So see guys, this is not the exact word which I have mentioned anywhere, but this LLM is helping me out, right? This LLM is helping me out based on what? Based on the data that I'm trying to pass and a query, right? Now I can try to ask a question over here that what was the company Sudhanshu has established. So I can try to ask any kind of a question with respect to, and the company Sudhanshu established is Euron. Yep, simple, right? It is able to give me an answer the way I was looking for. So this is the beauty of RAG. You can try to what is the birthplace of Sudhanshu? I can ask any kind of a question. I can ask like whatever I want, the way I want. And Jamshedpur, Jharkhand, India. Yeah, Jamshedpur, Jharkhand, India. Simple, right? So this is the beauty of RAG, guys. So now my LLM is able to answer based on my own data, right? Based on my own data. So that's the beauty of LLMs, and that's the beauty of RAG that we are able to achieve. So retrieve, augment, and then generate it, right? Retrieve, augment, and then generate it. So end to end, we are able to perform this kind of a operation. So with that, thank you so much, everyone. Hope all of you are enjoying it. And then in our next lecture, I'm going to convert the same thing I'll try to use, not different. I'll try to convert this entire things into a modular coding, and then what I will do is that I'll try to like host it somewhere. I'll try to deploy it somewhere. Yeah. So with that, thank you so much. Take care, everyone. See you again in my next lecture.